My name is Snehal Antani. I'm the co-founder and CEO here at Horizon 3. I'm going to talk to you today about why it's important to look at your enterprise through the eyes of an attacker. The challenge I had when I was a CIO in banking, the CTO at Splunk, and serving within the Department of Defense is that I had no idea I was secure until the bad guys had showed up. Am I logging the right data? Am I fixing the right vulnerabilities? Are my security tools that I've paid millions of dollars for actually working together to defend me? And the answer is, I don't know. Does my team actually know how to respond to a breach in the middle of an incident? I don't know. I've got to wait for the bad guys to show up. And so the challenge I had was, how do we proactively verify our security posture? I tried a variety of techniques. The first was the use of vulnerability scanners. And the challenge with vulnerability scanners is being vulnerable doesn't mean you're exploitable. I might have 100,000 findings from my scanner, of which maybe 5 or 10 can actually be exploited in my environment. The other big problem with scanners is that they can't chain weaknesses together from machine to machine. So if you've got 1,000 machines in your environment or more, what a vulnerability scanner will do is tell you have a problem on machine 1 and separately a problem on machine 2. But what they can't tell you is that an attacker could use a low from machine 1 plus a low from machine 2 to equal a critical in your environment. And what attackers do in their tactics is they chain together misconfigurations, dangerous product defaults, harvested credentials, and exploitable vulnerabilities into attack paths across different machines. So to address the attack paths across different machines, I tried layering in consulting-based pen testing. And the issue is when you've got thousands of hosts or hundreds of thousands of hosts in your environment, human-based pen testing simply doesn't scale to test an infrastructure of that size. Moreover, when they actually do execute a pen test and you get the report, oftentimes you lack the expertise within your team to quickly retest to verify that you've actually fixed the problem. And so what happens is you end up with these pen test reports that are incomplete snapshots and quickly going stale. And then to mitigate that problem, I tried using breach and attack simulation tools. And the struggle with these tools is, one, I had to install credentialed agents everywhere. Two, I had to write my own custom attack scripts that I didn't have much talent for, but also I had to maintain as my environment changed. And then three, these types of tools were not safe to run against production systems, which was the majority of my attack surface. So that's why we went off to start Horizon 3. So Tony and I met when we were in special operations together, and the challenge we wanted to solve was, how do we do infrastructure security testing at scale by giving the power of a 20-year pen testing veteran into the hands of an IT admin, a network engineer, in just 3 clicks. And the whole idea is we enable these fixers, the blue team, to be able to run NodeZero, our pen testing product, to quickly find problems in their environment. That blue team will then go off and fix the issues that were found, and then they can quickly rerun the attack to verify that they fixed the problem. And the whole idea is delivering this without requiring custom scripts be developed, without requiring credentialed agents be installed, and without requiring the use of external third-party consulting services or professional services. Self-service pen testing to quickly drive find, fix, verify. There are 3 primary use cases that our customers use us for. The first is the SOC manager that uses us to verify that their security tools are actually effective, to verify that they're logging the right data in Splunk or in their SIM, to verify that their managed security services provider is able to quickly detect and respond to an attack and hold them accountable for their SLAs, or that the SOC understands how to quickly detect and respond and measuring and verifying that, or that the variety of tools that you have in your stack, most organizations have 130 plus cybersecurity tools, none of which are designed to work together, are actually working together. The second primary use case is proactively hardening and verifying your systems. This is when that IT admin, that network engineer, they're able to run self-service pen tests to verify that their Cisco environment is installed and hardened and configured correctly, or that their credential policies are set up right, or that their vCenter or WebSphere or Kubernetes environments are actually designed to be secure. And what this allows the IT admins and network engineers to do is shift from running 1 or 2 pen tests a year to 30, 40 or more pen tests a month. And you can actually wire those pen tests into your DevOps process or into your detection engineering and change management processes to automatically trigger pen tests every time there's a change in your environment. The third primary use case is for those organizations lucky enough to have their own internal red team. They'll use NodeZero to do reconnaissance and exploitation at scale, and then use the output as a starting point for the humans to step in and focus on the really hard, juicy stuff that gets them on stage at DEF CON. And so these are the three primary use cases. And what we'll do is zoom into the find, fix, verify loop. Because what I've found in my experience is find, fix, verify is the future operating model for cybersecurity organizations. And what I mean here is in the find, using continuous pen testing, what you want to enable is on-demand self-service pen tests. You want those pen tests to find attack paths at scale, spanning your on-prem infrastructure, your cloud infrastructure, and your perimeter. Because attackers don't only stay in one place. They will find ways to chain together a perimeter breach, a credential from your on-prem to gain access to your cloud, or some other permutation. And then the third part in continuous pen testing is attackers don't focus on critical vulnerabilities anymore. They know we've built vulnerability management programs to reduce those vulnerabilities. So attackers have adapted, and what they do is chain together misconfigurations in your infrastructure and software and applications with dangerous product defaults, with exploitable vulnerabilities, and through the collection of credentials through a mix of techniques at scale. Once you've found those problems, the next question is, what do you do about it? Well, you want to be able to prioritize fixing problems that are actually exploitable in your environment that truly matter, meaning they're going to lead to domain compromise or domain user compromise or access to your sensitive data. The second thing you want to fix is making sure you understand what risk your crown jewels data is exposed to. Where is your crown jewels data? Is it in the cloud? Is it on-prem? Has it been copied to a shared drive that you weren't aware of? If a domain user was compromised, could they access that crown jewels data? You want to be able to use the attacker's perspective to secure the critical data you have in your infrastructure. And then finally, as you fix these problems, you want to quickly remediate and retest that you've actually fixed the issue. And this find, fix, verify cycle becomes that accelerator that drives purple team culture. The third part here is verify. And what you want to be able to do in the verify step is verify that your security tools and processes and people can effectively detect and respond to a breach. You want to be able to integrate that into your detection engineering processes so that you know you're catching the right security rules or that you've deployed the right configurations. You also want to make sure that your environment is adhering to the best practices around systems hardening and cyber resilience. And finally, you want to be able to prove your security posture over time to your board, to your leadership, and to your regulators. So what I'll do now is zoom into each of the three steps. So when we zoom into find, here's the first example. Using NodeZero and autonomous pen testing, and what an attacker will do is find a way to break through the perimeter. In this example, it's very easy to misconfigure Kubernetes to allow an attacker to gain remote code execution into your on-prem Kubernetes environment and break through the perimeter. And from there, what the attacker is going to do is conduct network reconnaissance and then find ways to gain code execution on other machines in the environment. And as they get code execution, they start to dump credentials, collect a bunch of NTLM hashes, crack those hashes using open source and dark web available data as part of those attacks, and then reuse those credentials to log in and laterally maneuver throughout the environment. And then as they laterally maneuver, they can reuse those credentials and use credential spraying techniques and so on to compromise your business email, to log in as admin into your cloud. And this is a very common attack, and rarely is a CVE actually needed to execute this attack. Often it's just a misconfiguration in Kubernetes with a bad credential policy or password policy combined with bad practices of credential reuse across the organization. Here's another example of an internal pen test, and this is from an actual customer. They had 5,000 hosts within their environment. They had EDR and UBA tools installed, and they initiated an internal pen test on a single machine. From that single initial access point, NodeZero enumerated the network, conducted reconnaissance, and found 5,000 hosts were accessible. What NodeZero will do under the covers is organize all of that reconnaissance data into a knowledge graph that we call a cyber terrain map. And that cyber terrain map becomes the key data structure that we use to efficiently maneuver and attack and compromise your environment. So what NodeZero will do is they'll try to find ways to get code execution, reuse credentials, and so on. In this customer example, they had Fortinet installed as their EDR. But NodeZero was still able to get code execution on a Windows machine. From there, it was able to successfully dump credentials, including sensitive credentials from the LSAS process on the Windows box, and then reuse those credentials to log in as domain admin in the network. And once an attacker becomes domain admin, they have the keys to the kingdom. They can do anything they want. So what happened here? Well, it turns out Fortinet was misconfigured on 3 out of 5,000 machines. Bad automation. The customer had no idea this had happened. They would have had to wait for an attacker to show up to realize that it was misconfigured. The second thing is, well, why didn't Fortinet stop the credential pivot and the lateral movement? And it turned out the customer didn't buy the right modules or turn on the right services within that particular product. And we see this not only with Fortinet, but we see this with Trend Micro and all the other defensive tools where it's very easy to miss a checkbox in the configuration that will do things like prevent credential dumping. The next story I'll tell you is attackers don't have to hack in, they log in. So another infrastructure pen test, a typical technique attackers will take is man-in-the-middle attacks that will collect hashes. So in this case, what an attacker will do is leverage a tool or technique called Responder to collect NTLM hashes that are being passed around the network. And there's a variety of reasons why these hashes are passed around, and it's a pretty common misconfiguration. But as an attacker collects those hashes, then they start to apply techniques to crack those hashes. So they'll hash the hash, and from there they will use open source intelligence, common password structures and patterns, and other types of techniques to try to crack those hashes into clear text passwords. So here, NodeZero automatically collected hashes. It automatically passed the hashes to crack those credentials. And then from there, it starts to take the domain user ID passwords that it's collected and tries to access different services and systems in your enterprise. In this case, NodeZero is able to successfully gain access to the Office 365 email environment because 3 employees didn't have MFA configured. So now what happens is NodeZero has placement and access in the business email system, which sets up the conditions for fraud, lateral phishing, and other techniques. But what's especially insightful here is that 80% of the hashes that were collected in this pen test were cracked in 15 minutes or less. 80%. 26% of the user accounts had a password that followed a pretty obvious pattern. First initial, last initial, and 4 random digits. The other thing that was interesting is 10% of service accounts had their user ID the same as their password. So VMware admin, WebSphere admin, so on and so forth. And so attackers don't have to hack in. They just log in with credentials that they've collected. The next story here is becoming AWS admin. So in this example, once again, internal pen test, NodeZero gets initial access. It discovers 2,000 hosts are network reachable from that environment. It fingerprints and organizes all of that data into a cyber terrain map. From there, it fingerprints that HP-ILO, the integrated lights out service, was running on a subset of hosts. HP-ILO is a service that is often not instrumented or observed by security teams, nor is it easy to patch. As a result, attackers know this and immediately go after those types of services. So in this case, that ILO service was exploitable, and we're able to get code execution on it. ILO stores all the user IDs and passwords in clear text in a particular set of processes. So once we gained code execution, we were able to dump all of the credentials, and then from there, laterally maneuver to log in to the Windows box next door as admin. And then on that admin box, we're able to gain access to the shared drives, and we found a credentials file saved on a shared drive. From there, it turned out that credentials file was the AWS admin credentials file, giving us full admin authority to their AWS accounts. not a single security alert was triggered in this attack because the customer wasn't observing the ILO service, and every step thereafter was a valid login in the environment. And so what do? Step 1, patch the server. Step 2, delete the credentials file from the share drive. And then step 3 is get better instrumentation on privileged access users and login. The final story I'll tell is a typical pattern that we see across the board that combines the various techniques I've described together, where an attacker is going to go off and use open source intelligence to find all of the employees that work at your company. From there, they're going to look up those employees on dark web breach databases and other forms of information, and then use that as a starting point to password spray to compromise a domain user. All it takes is one employee to reuse a breached password for their corporate email. Or all it takes is a single employee to have a weak password that's easily guessable. All it takes is one. And once the attacker is able to gain domain user access, in most shops, domain user is also the local admin on their laptop. And once you're local admin, you can dump SAM and get local admin NTLM hashes. You can use that to reuse credentials to gain local admin on neighboring machines, and attackers will start to rinse and repeat. Then eventually they're able to get to a point where they can dump LSAS or by unhooking the antivirus, defeating the EDR, or finding a misconfigured EDR, as we talked about earlier, to compromise the domain. And what's consistent is that the fundamentals are broken at these shops. They have poor password policies. They don't have least access privilege implemented. Active Directory groups are too permissive, where domain admin or domain user is also the local admin. AV or EDR solutions are misconfigured or easily unhooked, and so on. And what we found in 10,000 pen tests is that user behavior analytics tools never caught us in that lateral movement, in part because those tools require pristine logging data in order to work. And also, it becomes very difficult to find that baseline of normal usage versus abnormal usage of credential login. Another interesting insight is there were several marquee brand name MSSPs that were defending our customers' environments, and for them it took 7 hours to detect and respond to the pen test. 7 hours. The pen test was over in less than 2 hours. And so what you had was an egregious violation of the service level agreements that MSSP had in place. And the customer was able to use us to get service credit and drive accountability of their SOC and of their provider. The third interesting thing is, in one case, it took us 7 minutes to become domain admin in a bank. That bank had every Gucci security tool you could buy. Yet in 7 minutes and 19 seconds, NodeZero started as an unauthenticated member of the network and was able to escalate privileges through chaining and misconfigurations and lateral movement and so on to become domain admin. And if it's 7 minutes today, we should assume it'll be less than a minute a year or two from now, making it very difficult for humans to be able to detect and respond to that type of blitzkrieg attack. So that's in the find. It's not just about finding problems though. The bulk of the effort should be what to do about it, the fix and the verify. So as you find those problems, back to Kubernetes as an example, we will show you the path. Here is the kill chain we took to compromise that environment. We'll show you the impact. Here is the impact, or here's the proof of exploitation that we were able to use to be able to compromise it. And there's the actual command that we executed. So you could copy and paste that command and compromise that kubelet yourself if you want. And then the impact is we got code execution. And we'll actually show you, here is the impact. This is a critical. Here's why it enabled perimeter breach. Affected applications will tell you the specific IPs where you've got the problem, how it maps to the MITRE attack framework, and then we'll tell you exactly how to fix it. We'll also show you what this problem enabled so you can accurately prioritize why this is important or why it's not important. The next part is accurate prioritization. The hardest part of my job as a CIO was deciding what not to fix. So if you take SMB signing not required as an example, by default, that CVSS score is a 1 out of 10. But this misconfiguration, it's not a CVE, it's a misconfig, enabled an attacker to gain access to 19 credentials, including 1 domain admin, to local admins and access to a ton of data. Because of that context, this is really a 10 out of 10. You better fix this as soon as possible. However, of the 7 occurrences that we found, it's only a critical in 3 out of the 7. And these are the 3 specific machines, and we'll tell you the exact way to fix it, and you better fix these as soon as possible. For these 4 machines over here, these didn't allow us to do anything of consequence. So because the hardest part is deciding what not to fix, you can justifiably choose not to fix these 4 issues right now and just add them to your backlog and surge your team to fix these 3 as quickly as possible. And then once you've fixed these 3, you don't have to rerun the entire pen test. You can select these 3 and then one-click verify and run a very narrowly scoped pen test that is only testing this specific issue. And what that creates is a much faster cycle of finding and fixing problems. The other part of fixing is verifying that you don't have sensitive data at risk. So once we become a domain user, we're able to use those domain user credentials and try to gain access to databases, file shares, S3 buckets, Git repos, and so on, and help you understand what sensitive data you have at risk. So in this example, a green checkbox means we logged in as a valid domain user. We're able to get read-write access on the database. This is how many records we could have accessed, and we don't actually look at the values in the database, but we'll show you the schema so you can quickly characterize that PII data was at risk here. And we'll do that for your file shares and other sources of data. So now you can accurately articulate the data you have at risk and prioritize cleaning that data up, especially data that will lead to a fine or a big news issue. So that's the find, that's the fix. Now we're going to talk about the verify. The key part in verify is embracing and integrating with detection engineering practices. So when you think about your layers of security tools, you've got lots of tools in place, on average 130 tools at any given customer. But these tools were not designed to work together. So when you run a pen test, what you want to do is say, did you detect us? Did you log us? Did you alert on us? Did you stop us? And from there, what you want to see is, okay, what are the techniques that are commonly used to defeat an environment, to actually compromise? If you look at the top 10 techniques we use, and there's far more than just these 10, but these are the most often executed, 9 out of 10 have nothing to do with CVEs. It has to do with misconfigurations, dangerous product defaults, bad credential policies. And it's how we chain those together to become a domain admin or compromise a host. So what customers will do is every single attacker command we executed is provided to you as an activity log. So you can actually see every single attacker command we ran, the timestamp it was executed, the hosts it executed on, and how it maps to the MITRE attack tactics. So our customers will have are these attacker logs on one screen, and then they'll go look into Splunk or Exabeam or SentinelOne or CrowdStrike and say, did you detect us? Did you log us? Did you alert on us or not? And to make that even easier, if you take this example, hey Splunk, what logs did you see at this time on the VMware host? Because that's when NodeZero is able to dump credentials. And that allows you to identify and fix your logging blind spots. To make that easier, we've got app integration. So this is an actual Splunk app in the Splunk App Store. And what you can come is inside the Splunk console itself, you can fire up the Horizon 3 NodeZero app. All of the pen test results are here so that you can see all of the results in one place and you don't have to jump out of the tool. And what you'll show you as I skip forward is, hey, there's a pen test. Here are the critical issues that we've identified. For that weaker default issue, here are the exact commands we executed. And then we will automatically query into Splunk all terms between these times on that endpoint that relate to this attack. So you can now quickly, within the Splunk environment itself, figure out that you're missing logs or that you're appropriately catching this issue. And that becomes incredibly important in that detection engineering cycle that I mentioned earlier. So how do our customers end up using us? They shift from running one pen test a year to 30, 40 pen tests a month oftentimes wiring us into their deployment automation to automatically run pen tests. The other part that they'll do is as they run more pen tests, they find more issues, but eventually they hit this inflection point where they're able to rapidly clean up their environment. And that inflection point is because the red and the blue teams start working together in a purple team culture. And now they're working together to proactively harden their environment. The other thing our customers will do is run us from different perspectives. They'll first start running an RFC 1918 scope to see once the attacker gained initial access in a part of the network that had wide access, what could they do? And then from there, they'll run us within a specific network segment. Okay, from within that segment, could the attacker break out and gain access to another segment? Then they'll run us from their work from home environment. Could they traverse the VPN and do something damaging? And once they're in, could they traverse the VPN and get into my cloud? Then they'll break in from the outside. All of these perspectives are available to you in Horizon 3 and in NodeZero as a single SKU, and you can run as many pen tests as you want. If you run a phishing campaign and find that an intern in the finance department had the worst phishing behavior, you can then inject their credentials and actually show the end-to-end story of how an attacker phished, gained credentials of an intern, and used that to gain access to sensitive financial data. So what our customers end up doing is running multiple attacks from multiple perspectives and looking at those results over time. I'll leave you two things. One is, what is the AI in Horizon 3 AI? Those knowledge graphs are the heart and soul of everything that we do. And we use machine learning, reinforcement learning techniques, Markov decision models, and so on to be able to efficiently maneuver and analyze the paths in those really large graphs. We also use context-based scoring to prioritize weaknesses, and we're also able to drive collective intelligence across all of the operations. So the more pen tests we run, the smarter we get. And all of that is based on our knowledge graph analytics infrastructure that we have.